Hello, my name is Chamindu. I'm here to present my dissertation titled Digitization of Workflow on Manufacture and Assembly Elements Integrated Facade Renovation. My presentation will include a short introduction to the topic and how I formulated my workflow with process models and digitization strategy, and of course the practical application of the case study. And I will finish off the presentation with key takeaways. Facade renovation in AEC industry could happen for various reasons, such as to improve energy efficiency, for better occupant safety and health, and as well as for repairs and maintenance. It also involves a lot of professionals, such as surveyors, manufacturers, technicians, and of course the BIM team and architects and engineers. And there are a lot of methodologies and technologies used in this workflow also, such as fabrication of panels, simulations of models, and computational designs, and point cloud surveys as well. By analyzing this workflow, I came across this problem statement, which is generating a mesh model from the point cloud using the proprietary software, which is labor intensive and manual work, and also it lacks information. The other one is the lack of information requirement and exchange in the project connecting the design and construction stage. This can be identified as the fragmented nature of the project teams. Based on this problem statement, I came across these objectives for my research, that is to identify the processes, actors, data, and tools, and to generate a digitization strategy, as well as to use open BIM standards and open source software for the implementation. The methodology I followed in the research includes the assistant to be process models, and then the digitization strategy, and of course the practical application. The case study used in this research is from Fraunhofer Italia company in Italy, which comprises a point cloud survey of a two-story residential building that has enough details of the facade, including doors and windows, external walls, some steps, and of course the ceiling as well. And I use Blender and Blender BIM as open source software for IFC authoring, as well as Python libraries such as IFC OpenShell and Open3D, and Cloud Compare also for point cloud operation, which is open source software. So in the as-is process model, there are 4 main stages, which start with the 3D building survey, and then move on to creating the as-built BIM model with the survey, and we can do the facade design, then move on to the final stage, which is manufacture and assembly stage. The proposed to be model has 2 main differences that I like to highlight. That is to automate this as-built BIM model creation, as well as to have a fabrication simulation within the facade design stage, because to have that feedback from the manufacture and assembly stage within the facade design stage would increase the efficiency and would really omit any future major changes or revisions that could result in time and cost for the project. These to-be process models were further refined to sub-process models, and I will highlight key parts in these sub-process models quickly. So to start, in the A1 sub-process model, which includes the survey, this is to be start with proper EIR. And in the A2 sub-process model, the main highlight is to automate the as-built BIM model, as well as to validate the generated BIM model. And in the design stage, which is the A3 sub-process, we can have the preliminary fabrication simulation within the conceptual design stage of the facade, and where if they require any revisions later on from the manufacturing assembly stage, and it will be easily done in the facade design, detailed design stage. And all the feedback from the manufacturing assembly stage should be passed through to the process stages above also. Based on this to be process models, I came across with this strategy for digitization that has a vision to use open BIM and open source tools and technologies, and which also encompasses 8 objectives. Focus of this study would be to 3 objectives: the exchange information requirement, point cloud to BIM model automation, and the collaboration. So firstly, we will look at the EIR, the exchange information requirement. This model represents the data exchanges and requirements happening within the project team. The project team has 3 teams inside, which has a surveying team, which encompasses technicians and site survey team, and the design team, which has a BIM team, and with architects and engineers, and finally the manufacturing assembly team. The information exchange start with the BIM manager issuing the guideline for surveying for the survey team, and ends with BIM manager issuing the project information model and asset information model to the client party. The basis for this information exchange and requirement diagram is to have an information requirement prior to producing any information, as well as the task of the BIM specialist, which is to automate the point cloud to BIM model, as well as doing the fabrication simulation. Then we move on to the second objective, which is the point cloud to BIM. First, I use Cloud Compare to further pre-process the point cloud model, which I received from the company. When I received the model, it was already registered, but I had to further reduce the model size using operations on the point cloud, cloud subsampling, as well. I had to do the normal estimation of these points, so it would be possible to have more operations in later stages. Then this process point cloud was imported to Blender. Within Blender, it is somehow limited to do operations on the point clouds to make it a volume and make it a mesh. So using the geometry node, as you can see here. As well as I try to use Blender Beam to manually model some walls and windows, and it gives the user a lot of customization, and you can make a very information-rich model by incorporating property and quantities as needed. Also in Blender Beam, with its scripting functionality, we can use IFC OpenShell scripts, such as these 2 examples, which I got from C-Klaus or in GitHub. Using these scripts, we can generate parametric BIM models, and we can manipulate the figures and make BIM models using this IFC OpenShell script. As well as these scripts can be used to visualize the model in real time within the Blender also, which is a good thing. And finally, using Open3D script, I could identify planes in this point cloud, which corresponds to walls, the ceiling, and the floors. And using the settings in this planar segmentation, I could further refine it to identify the planes I specifically want, and then visualize it, and also writing those information in point and mesh files. And you can see on the right side, those mesh and point files could be imported to Blend as well. For the third objective, collaboration, using IFC JIT functionality in Blender Beam, we could save locally the information of this IFC model, as well as we can link it to a remote repository, such as in GitHub, as you can see in this example. So all the JIT workflow could be carried out with these IFC files. So based on this IFC JIT collaboration, BIM and AEC tasks like energy simulations or specification writing or such tasks like that could be done using the fork clone workflow using a remote repository like GitHub. Also, with this JIT workflow, you could have the history of revisions also. And with the exported mesh and point files, we could extract the coordinates of these planes, which could be the inputs in an IFC OpenShell script, specifically in IFC cards and points, and then we could move further into make it solid BIM objects using this spatial hierarchy. To conclude my presentation, I would say the OpenBIM and use of open source software solution represents a direction to improve collaboration, data exchange in these specific BIM processes. Also, open source software used in this research, like Blender BIM and IFC OpenShell, presents an interesting alternative to proprietary software and opens up new possibilities for digitization of the construction industry. One obstacle I found in this workflow is the software literacy and programming knowledge as specialized skills, but there are a number of tutorials and open source community backing up to gain this information. As for the future development, I would suggest to have these 3 tasks within Blender to start with Open3D script to identify plane patches for walls, and using IFC OpenShell, we could get the coordinates from those planes and generate the external walls. And using Blender BIM, we could IFC author complex elements such as windows and also validate the as-built BIM model. Thank you for listening.